All right, so we remember, rules are rules. We follow them no matter what. Next, in the 9th grade, raising an exponent to an exponent. What that means is I start with a base and an exponent. So in grade 9, we use numbers, right? In grade 10, we're starting to use variables. So I start with a number with an exponent, and then that whole power gets another exponent. Now, a great many of you already know the shortcut, but just to remind you, what does this mean? What is the base in this expression? X squared is the base. So, and that 3 means x squared is happening how many times? Thrice. Now, we remember from the first law that when I multiply, I add, right? So 2 plus 2 plus 2. But math guys have given us a shortcut to addition over and over again. What is it? What do we do instead of adding? We multiply. So when we are adding the same thing over and over, we can multiply. So this is x to the 2 plus 2 plus 2, which is the same as x to the 2 times 3. So whenever we have an exponent to an exponent, it multiplies. The rule is x to the m to the n equals x to the m times n, which is going to show up in a minute. And then I'll highlight it in blue like I highlighted all the others. Now I'm going to stop here for a moment to remind you of something. Each one of these exponent laws is an independent thing. But every one of these exponent laws applies in every case. All right? So it's not enough just to know them. You also need to be aware that all of them apply all the time. So you may get one exponent question that requires you to use all 7 of these rules that I am giving you in one question. Okay? So you got to be careful with these. It's not enough to just know them. You had a question?
No, I was talking about that it has to be grade 9 where we had to use the raising
I know, right?
really hard.
I know. Math. Wow. Imagine making a rocket ship land on Mars is difficult. You might have to do some complicated math to do so. All right. So, next, a fraction base. Okay. Now here's where we start. Those first 3 are the basis for everything else. If you actually understand the first 3, the rest of them aren't going to be a problem. We're going to start with this one. So if I have a fraction, x over y. This particular one I got this year because the one I got last year fell off my desk. In true North American fashion, I say it fell off my desk, but what really happened is I got up, kicked the power cord, and pulled it off my desk. But in North American fashion, it fell. It wasn't my fault. It was totally my fault. I was a clumsy oaf. So then they gave me this one. The other one got returned to the people we bought them from to get a new piece of glass put on the front. Because it wasn't broken. It still worked. It just, much like when you guys drop your phones. Well, I lie. When your phones fall. Because you don't drop them. It's not your fault. Your phone just jumps into the toilet. All right. Read the question here. It says I have a fraction base with an exponent. What must I do to this fraction to make sure all of it is the base? Brackets. Excellent. And now I give it an exponent, squared. What does that squared mean? It means that base is going to repeat twice, right? So I'm going to get x over y 2 times. Correct? Everyone agrees, yeah? Okay. Now, think back to grade 4 when you were learning to multiply fractions. When I multiply fractions, and I'm talking slowly to wait for the computer to catch up to me because it's a piece of garbage and it's still not there yet, and I'm running out of breath and I'm getting a little bit dizzy and I'm hoping that it will catch up very soon, but it hasn't. When you multiply fractions, you go numerator, numerator, denominator, denominator, yes? Okay, so x, what exponents do they have? 1, and what do I do with those exponents when I multiply? Add them, so I have x squared over y what? Squared. Easy peasy, right? What's the shortcut rule? X over y to the m is x to the m over y to the m. The m goes everywhere, or the exponent goes everywhere. Is everybody good with that one? Okay. An exponent of 0. X to the 0. In grade 9, you should have been taught x to the 0, and you probably remembered that it equals 1. Now, there's a problem with this because, like I said earlier, every single exponent law applies. Okay? So I want to show you why this works, because can get a little confusing. What if I told you I had x to the 5th over x to the 5th? What math is that when it shows up? It's x to the 5th over x to the 5th. What math is that? Division. Excellent. What do we do when we divide? Subtract. So this would be x to the 5 minus 5, yes? Which would be x to the 0, yes? Everyone agrees? Okay. What if I told you I had 3 over 3? It'll show up in a second. What is 3 divided by 3? 1. Okay, everyone agrees? Right? It's like grade 1 math, right? Hey, anybody who watches the videos once in a while, do these pauses show up on it?
I don't know. I don't think so. Yeah, well, I don't know. That was not yesterday. It was the day before.
Well, I'm just wondering if maybe the whole computer stops working, including the screen record.
Yeah.
Which would mean that all my jokes about how crappy it is and the time it's taking aren't showing up on the recording.
No, that shows up. It just goes blank. It just stays still.
But you can still hear my voice?
Yeah.
Sweet. All right. So, what is 3 divided by 3? 1. Everybody cool? Now, you guys already know from math that anytime you have something the same on the top and bottom, we say we cancel it out. But what are we really doing? We're actually doing that division, yes? So notice that anytime I have the same thing in the numerator and the same thing in the denominator, it equals 1. So x to the 5th over x to the 5th, it's the same thing, yes? So it equals x to the 0. But if the same thing on top and same thing on the bottom equals 1, then x to the 0 must also equal 1. Does everybody understand? That is why it works. But there's a warning here, because remember, every other exponent rule applies. What is the base here? X. So x to the 0 is 1, correct? Okay. Okay. Then what is the base here? X. So what's the answer? -1. Why? Because the x is the base. And any base to 0 is 1, but then there's a negative out in front. What then is this? Ryan? 1. Why? Because now the negative is part of the base. And any base to the 0 is what? 1. Everybody sees this very subtle difference, yes? Yep. The brackets make the answer change. Everybody good? All right. So the rule is x to the 0 equals 1. Now you may want to add in the other two situations. Negative x to the 0 is -1, and negative x to the 0 is +1. You may want to write those in red or in over on the side with the rules just to remind you of that. Eventually it'll show up. I can't even slide down to the next thing. While you're writing your quiz, I'll be doing the old turn the computer off and restart thing to see if that helps. You know, that tech support thing when you call tech support. My computer doesn't work. Did you turn it off and on? It works. And then you think tech support's a genius.
It makes it slow.
It makes me angry because whenever I have to call tech support, I always say, I've done this, and this. And then you hear clickety, clickety, clickety while they search through to get to the 20th step because you've already done the first 20 steps of what they know how to do. All right. Number 6. 2 different bases raised to the same exponent. Now this one is not tricky, right? xy squared. That looks a lot like a fraction, doesn't it? So in a fraction, the exponent went to everything because it was x over y times x over y, right? So what's my base here? xy. So it's xy times xy, which is the same as x times y times y. Since x's are the same base, what do we do with the exponents? Add them. And since y's are the same base, what do we do with the exponents? Add them. Are x and y the same base? No. So can I do anything with these exponents? Yes or no? No, because they're different bases. So the rule, when it shows up, is just like the fraction one. The exponent has to go everywhere inside. Now you'll notice I've left a lot of white space here below a pretty simple rule, right? You've already seen that rule with the division one. So why have I left this much space here? Because now is the end of all the stuff that makes perfect sense. 99% of my students are aces up to number 7. It's number 7 that's going to screw you up. So we're going to take a bit of time with this white space here and work with it a little bit. The rule here, xy to the m is x to the m, y to the m. It goes everywhere inside. Now, I've said it about 7 times today, just to make sure. If you've been paying attention, you've heard me say it at least 7 times. Every rule applies to every question. Okay? So I'm going to give you something that looks a little weird and see if you're okay with it. I'm going to do these in blue. This is your first example. 3x squared. Every rule applies. What's the base? 3x. Is that base in brackets? Does what I just drew in blue look exactly like what I just wrote in black? Okay, so which rule applies? Number 6, yes? So what happens here? Both parts of the base get the exponent. So what does 3 become? 3 squared. And what does x become? X squared. And we would never leave 3 squared because we can evaluate that. 9x squared. Everybody good? Everybody good? Okay. Now, what is 3x squared? Squared. It'll show up in a sec. One hopes. Okay, what's that one going to be? Build on what you already know. This looks a lot like this, but it has the addition of that rule. So look back in your rules and figure it out. Some of you already know. What's that one going to be? What's going to happen to the 3? Three squared. What's going to happen to the x? X squared plus x squared? I'm going over brackets. Doesn't that look like number 3?
Oh, sorry. X.
2 times 2 to get 9x to the 4th. Is everybody okay there? Yeah? Okay. What about this one? Three x squared, y squared, squared. What's that one going to be? 3x squared, y squared, all squared. What's that going to be? Is everybody cool there? Please notice that it's all the same rules. They're just getting a little stretched out. Everybody's okay? All right. What about this one? This will be the last one we do before we go on to negatives, which you'll notice I have left 3/4 of a page to explain. 3 3x squared, y squared, x to the 4th squared. Now what do you got to do? Because there's more than one way to do that last question. Remember, every rule applies. Okay, who would like to risk this one? I know you know how to do it because you've already seen this. Ryan. Absolutely correct. Why? He had two choices for how he would do it. Ryan, what did you do? So you multiplied that in and got 4, 8, and 2, and then recognized x and x were the same base and added. He also could have done that inside the brackets. He could have gone 3x to the 6th y squared because x and x could be added inside. Did it matter which way he did this? No. But his knowledge of all the exponent laws allowed him to work it through. Nobody had to do it that way. You could have also done this. And then this all would have been squared. And it would have been 3 squared, x 6 squared, 6 times 2, y squared times 2 to the 4th. Is everybody good up to the end of exponent law 6? Everybody? Okay. Now we move on to the thing that actually makes this difficult. Negative exponents. What does an exponent tell us to do? Tells us how many times you're going to multiply something, yes? So don't write this down. Just quick reminder, do not write this down. Well, you can't write anything down. I'm going to do what always works. A whiteboard. X squared means what? Means x times x. X to the 5th means x, 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 right? Makes perfect sense. Agreed? Does that make sense? Why not? How can you multiply something by itself negatively? It makes no sense, does it? Everybody agrees that this makes no logical sense, yes? Because there's no way to write it out like these two, is there? Everybody cool? Now, some of you already know what is going to happen here, and that's fine. But most of you don't. So, we're going to do something with this. This is the problem that we are facing. Something to a negative exponent. X to the negative 2, for example. What does that mean? And it makes no sense. So I would like for all of you to write the following on your piece of paper somewhere under negative exponents, right here where it says negative exponents. Start with this. 2 cubed equals what? It equals 2 times 2 times 2, which equals what? 8. Everyone agree? Yeah. Okay. 2 squared equals what? 2 times 2, 4. What is the relationship here? I have taken away one of my multiplications, which is the same as dividing by 2. Does everyone agree? Everyone's cool? Okay. What's the next one? 2 to the 1. How many 2's is that? 2, 2, and I've divided by 2 again, haven't I? What's the next logical exponent? 3, 2, 1, 0. Which means there's no 2's, and we know that that equals 1 from exponent law 5, right? This is again divided by 2. You're smart individuals. I have repeated divided by, divided by, divided by. What is the, and I've gone 3, 2, 1, 0. What is the next logical exponent? 2 to the negative 1. I don't know what that means. It doesn't make any sense. But use your brain. What is the logical thing to do here? Divide by 2. What is 1 divided by 2? 1/2, right? What is the next logical exponent? 0, -1, -2. Divide by 2 again. What happens when I cut a half in half? I get a quarter. Everybody see? The next logical one is 2 to the -3rd, -3. What's this going to be? 2, 4, 2, 4. So what's that? 1/8. Does everybody see? Everybody gets it? So that tells us that's interesting. That's a new one. So that tells us what we just did. 2 squared, 4, 2, 1, 2, 2, 0, 1, 2, -1, 1/2, 2, -2, 1/4. What does this tell us? That x to the -m is the same as 1 over x to the +m. Does everybody understand that? The negative gives us the same value, but it's reciprocated. Is everybody cool? Yeah? Okay, now I'm going to use, notice again, I've given you a whole lot of blank space here to explain this. I'm going to explain it in another way because some people really don't see this. So I'm going to show you something else. Remember in exponent law 2 when I said x to the 3 over x to the 5th. And I told you it was x to the -2 because rules are rules, right? This is why it works. What is this really? Right? What is this really? Five x's, right? What do I get to do with 3 of those x's? Cancel them out, and I'm left with 2 x's in the denominator, which would be x squared, yes? Now, there's nothing up top. Can I put 0 there? No, because if I put 0 there, I have 0, don't I? And I don't have 0 things. I have this thing cubed divided by this thing to the 5th. That's not 0. So what is the number that we write, that we don't write in multiply? It's fine. What is the number that we don't write in multiply and dividing? 1. So what number logically goes on the numerator here? 1 and 1. And that is the same thing that we just proved here with numbers. Is everybody cool? What is your takeaway from this? Negative exponents cannot exist. They must be reciprocated. Does everybody understand? Yeah? Okay, so now if you all understand that, you understand what reciprocate means. It means flip a fraction. What then would you do if I gave you this? What is wrong with that red expression? Michael?
There's the negative exponent
there is a negative exponent. Can they exist? No. Which means that negative exponent must be reciprocated. Well, it's already in the denominator, so where must it go? It reciprocates to the numerator. Everybody good? Yeah? All right. What would happen if I gave you this? Y to the negative 3 over x to the negative 2. What's wrong with that one? There's a negatives everywhere. Are negatives allowed to exist? No. So where does this numerator have to go? To the denominator. And what happens to its exponent? Becomes positive. Where does this one go? Numerator. What happens to its exponent? Positive. Please notice that all I did was flip and change the fraction, or change the exponents. Is everybody good? Okay. Now let's see if you can remember everything else. 3x to the negative 2. What's the base there? Is it? X is the base. What's not allowed? A negative exponent. What does that negative exponent apply to? 3, x, or both? Just x. So is the 3 going to get touched? No. So it is 3 over x squared. Makes perfect sense, right? Just like all the other rules. What if I made it this? Now what is it? What's the base? 3x. So where does it have to go? Down here. And it's 3x squared. But what do I have to do here? We've already done that like 18 times today alone. What does this become? 1 over what? It's right on your page, just above where we were working. It's right on your page, just above where we're working right now. That exact thing. What is it? You waited, hopefully. No. 9x squared. See how it's right there? Everybody cool? And then the very last thing that is going to mess you guys up more than anything is this. What is negative 3? X to the negative 2. What's the only thing there that isn't allowed? Negative exponent. Is that okay? Yes. So that still stays negative 3 over x to what exponent? Positive 2. Negative bases? Okay. Negative exponents? Everybody good? All right, now, that's everything you need to know. And if you look in your book, the next 2 pages are exponent practice. You are going to do all of 81, and you are going to do the circled questions, all of 81 and 82, I lie, and the circled questions on 83 and 84. I think it might only be 83. 83 and 84, just the circled questions. Everybody cool? Okay, I'm going to give out the trig quiz in a second. You're going to write the quiz. Then you're going to open up your Outrageous Orchid book and work on these exponents until everybody's done the quiz and we can mark it. If we have time, we'll mark it today. If not, well, no, I really want to mark it today because I want you to have it to study for your test tomorrow. All right? So the quiz stops at 9:40 or at 10:45. That gives me 10 minutes to mark it. Okay? You have half an hour to write this quiz. Yes. And then after you write this quiz, you go back to the exponents in your Outrageous Orchid book.